Now we are going to talk about the projectile motion. So first I will derive the formula of the projectile motion, and then we will come to our real problem and its solution. So now if we draw a simple projectile, so this is y-axis and this direction x-axis, and we put a projectile like this, and the angle of the initial velocity u to the x-axis is theta. So if we throw the projectile as we see in this direction, then it has two components. One is along x-axis, another one will be along y-axis. Now we know that x-axis component, if we denote as ux, so ux will be u cos theta, and if we consider y-axis component as uy, then uy will be u sin theta. So these two things we know, and everywhere if you draw the tangent, it will have two components. One is along x-axis, another one will be along y-axis. So like this we can find the velocity at any point along x-axis and along y-axis. Another few important things we need to remember when we are dealing with the projectile: the component along x-axis, acceleration component along x-axis, ax if we denote, so it will be 0, and component along y-axis, ay, will be minus g. So we are considering y in upward direction, but gravity always works in downward direction, and for that reason that minus sign comes. Now if we just see from these two formula, the displacement, if you see the displacement along x-axis, so we need to find out, let's say, the maximum displacement. So most of the problems you will see that maximum displacement along x-axis and how long it takes to go to that maximum displacement along x-axis. So to do that we have to use our same formula. So now if we have to find out the maximum height of the projectile, so then at maximum height, let's say maximum height is h, and at maximum height we will have the velocity, y component of the velocity will be 0. So Vy will be 0 at maximum height. So then if we put the formula, V equal to u minus g t. So t we are denoting at maximum, to reach maximum height, how long it will take. So t is the time to reach maximum height. Okay, so here you will see th equal to u by g. So this is the time it will take to reach the maximum height. Okay, now from another equation, if we see v square equals to u square, so v square, v is 0, v square equals to 0, so it will be u square minus 2g into h. So what will be the height of that maximum reach? So here h, it comes to u square by 2g. Now remember one thing, this is the u, but component of velocity u along x-axis will be, as you know, uy. So this will be uy, this will be also ui, this will be also ui, because it has two components. That y component, ui component, will help the particle to move or reach maximum height. So same way it will be ui. So in this case, the maximum height for the projectile, the time takes to reach maximum height, it will be u sine theta by g. So this is important formula we need to remember. And to reach maximum height, h will be u square sine square theta by 2g. So for the projectile, this is the another formula that you need to remember. Now let's say this is the total distance. So total distance, this is the total distance that projectile will drop here in this total distance, and this distance let's consider is s. So s equal to ux t, because this component velocity is ux, plus half ax t square. Ax equals to 0, we know that, because there is no acceleration along x-axis. So the maximum distance s will be ux into t, so it will be u cos theta into t. So this is the maximum distance, maximum horizontal distance covered by projectile along x-axis. So here horizontal means it is x-axis in our calculation, so it is coming s equal to u cos theta into t. Okay, now another important point we can see here, at maximum distance the y will be 0, means there is no height. At this distance y will be 0, and at t equals to 0 y will be 0. But at this time, so y will be 0, then we can put, if we consider the y direction, then it will be 0, then it will be uy t, because at same time it will also be the t for, if we consider the component of displacement along y-axis, so it is 0, then minus half g t square. So this is the same time for x direction, this is the displacement, for y direction displacement is 0, and from this equation we get t equal to two ui by g, and if we put the value of ui, so 2u sine theta by g. So this is the total time of flight. This is total time of flight. Total time of flight of the projectile. Okay, so these are very important concept when we deal with any projectile motion, and we'll use the same formula in our problem solution.